Hi, this question 17 is about the heat engine, and here in the options they mention the first law of thermodynamics and the second law of thermodynamics, and thermodynamics is topic B4 in the HLIB program. Okay, so what is first law of thermodynamics about? It's basically about the conservation of energy. So if a system receives an amount of energy under the form of thermal energy is heat, get like it's got heated up, then all the molecule inside the system will have a higher kinetic energy. It will move around faster. That means that it have a higher internal energy is here. Okay, so it will have a change in the internal energy, and also it have the ability to do work to the surrounding, okay, to the outside surrounding. So basically by the Clausius sign convention, you will see that if the system receives the heat, then that heat should be greater than zero. If it have an increase in the internal energy, then this delta U should be greater than zero. And also if the system is doing work to the surrounding, then the W here should be like greater than zero. So sometimes you may find like, oh, there's another way to write this one, that is delta U equals to Q plus word W. Just pay attention that W here means that the work done on the system, okay? So this is like how the surrounding is doing on the system. So this kind of work is like just on the opposite side with this one, okay? I just want to remind you, like if you come across this one, it is just another way to write the first law of thermodynamics, okay? But in order not to be confused, we will just like stick to this one, okay? And just remember that the work done by the system should be greater than zero when we write this form, okay? The second law of thermodynamics stated like this: energy cannot be transferred from a body at a lower temperature to a body at a greater temperature unless work is done on the system. So basically it's saying that by natural flow, the energy should flows from a higher temperature to a lower temperature. That's it, right? And when we want to express this law in forms of mathematical, we have two ways. The first way is that by the heat engine efficiency. So that will be either equals to the amount of heat supply from the hot source subtracted by the amount of heat lost that is being dumped into the cold reservoir, and then divided by the initial supply heat, okay? So the efficiency here never can reach 1, right? It's never that perfect. It's always less than 1. And by the Carnot cycle, it can be related to the temperature of the initial hot source to the temperature of the cold reservoir, okay? Another way to write the second law of thermodynamics is that the change in the entropy equals to the amount of heat received divided by the temperature, and the entropy by nature always like greater than or equals to 0. It means it's never decreased. It's always stay the same or increasing, okay? So back to this point here, let's see this one. We see that from, you can see that follow the arrows, right? This is the hot source of energy, right? And then it go into the system here. It provide 100 joule, and then seems like it doing a amount of work is 30 joule, and then it's also like dump an amount of energy, like wasted energy here 70 joule to a cold reservoir here. So then we can see that 100 joule is the input, right? The total, and then 30 joule here is the work done, and then this is like the wasted energy to the cold reservoir. So they equal to each other, right? So I could say like, seems like energy, the energy is conserved in this case. So it doesn't violate the first law of thermodynamics. So here they mention it's violate, that's not true. So there's no way that we should choose either option B or option D, right? Because it doesn't violate the law of thermodynamics. For the first A option, it said that perfectly possible heat engine. If it's a perfectly possible heat engine, then the efficiency, the either should be 100%, right? But this is not the case here, and we know that in fact there's nothing like a perfectly possible heat engine, right? So that's not A either. And now let's just have another look at the second law. So does it violate the second law? We can say that, okay, we got this is a hot source here, and this is a cold reservoir. This is actually like higher than this one, so it seems like it should be correct, right? But if you have a closer look at the efficiency, you can see that for this one here, we see that the hot amount heat is like 100 joule. The wasted one is like 70 above the initial one. So actually the efficiency, just like the ratio between the work done and the total initial energy, is just like 30%, right? If we follow this one. But if we apply the Carnot cycle here, we can see that 1 minus the temperature of the cold reservoir should be like 600 Kelvin over the initial hot temperature to be like 800 Kelvin. Oh, sorry, something wrong with my pencil here. Okay. So we can see that this one actually that's why will be 1 subtracted by 3 over 4 to be just like 25%, right? So there's a mismatch in here. They're not the same in here, right? So it seems like it violates the second law. Okay, so that's why C is the option. Sounds good? Okay, let me know if something isn't clear. Thank you.